In this video, we're going to find the area of a triangle determined by 3 points. So we're given the points negative 1, 3, 1, 0, 5, 2, and 4, 3, negative 1. We're first asked to find a vector that's orthogonal to the plane determined by P, Q, and R, and then find the area of the triangle determined by P, Q, and R. We can check pretty quickly that the 3 points are not on the same line. Easiest way to do that, start at P, go to Q, start at P, go to R. If the two vectors that you find are parallel to one another, then those 3 points are actually on the same line, and now we don't have a plane to consider anymore. The vector from P to Q, if we do the difference of the components, Q minus P, we'll get 1, 2, 1. And then from P to R, we'll get 5, 0, negative 2. And certainly, those vectors are not scalar multiples of each other. So those vectors are not parallel. So we have 3 non-collinear points. So we can actually talk about the plane determined by those 3 points, or those two vectors, if you will. If we want a non-zero vector orthogonal to the plane, we really mean a non-zero vector orthogonal to these two vectors. So we'll take their cross product. When we take the cross product, eliminate the row with I and the column with I in it, we're left with the determinant of the 2, 1, 0, negative 2. Multiply that by the I. Do the same thing for J. We're left with the determinant 1, 1, 5, negative 2. Remember, we have to do the opposite for the one for J. For K, we've got the determinant for 1, 2, 5, 0. 2 times negative 2 gives us negative 4. And then minus a 0, so we get negative 4i. Negative 2 minus 5 gives us a negative 7, but there's a negative sign in front, so we get a positive 7j. 0 minus 10 gives us a negative 10k. So this is the non-zero vector that they're looking for in that first part, a non-zero vector that's orthogonal to the plane that contains P, Q, and R. Finally, to find the area of the triangle, well, we've got PQ and PR would determine a parallelogram. If we do half the area of the parallelogram, that'll give us the area of the triangle we're looking for. The area of the parallelogram, of course, is the magnitude of the cross product. So we'll do 1/2 times the magnitude of the cross product. And the magnitude of the cross product, of course, then will be square root of negative 4 squared plus 7 squared plus a negative 10 squared, or square root of 165. So our area is 1/2 of that. So the 1/2 of the square root of 165.